Hello YouTube, Alan Barr, Internal Tools, Platform Product Person here with a topic that is timeless, and that is API Design, Application Programming Interface. It sounds complicated, and it is a complicated topic, but to make it a little bit more simple, when we talk about interfaces, it's really much easier to look at a visual, and the simplest thing we can think of is a light switch. So that is a simple interface that you interact with a complicated procedure that is turning on lights that we use every day. And when we do software development, what we're attempting to do is create products, interfaces that others can use to build upon. The way you can think of this is Legos. As we're building, there are limitations to what we can build. There are challenges with what we build. And the reason there are challenges is because we make decisions in the process of building an API that we don't often see causes problems for us in the future. The sooner that we can make a decision in a way that prevents problems in the future. The goal of API design is, over time as an organization, you're learning what works and what doesn't work. Where we fall down in businesses of software engineering teams that create APIs is we're not learning the lessons early enough. As you're aware, people come in, people leave, their knowledge leaves with them. Ultimately, in a business, we want to be growing and learning from our practices. It's the only way we're going to be getting better. The problem with API design is it's hard, it's very challenging, it's very difficult, and it is only one particular facet of software development. And when I speak about API design, I'm simply talking about RESTful HTTP APIs that we describe using the Open API specification format. Now, there's a lot of other kinds of APIs you can design. Those can be within a software package using your primary language of choice, or that is the API you're offering to other companies or other individuals. Not all of them are going to be given to the whole world. Some might be just for your own use, or there might be others that are for a broader use case, but they're in a narrow realm of a business. The bigger the audience there is, the bigger amount of people that are going to be using it, the harder it's going to be change. We need to be mindful of our decisions and choices because APIs are forever. So I'm going to share with you some notes that I'm taking on API design. I'm reading through a few books and I haven't completed them totally yet because they're very dense and there's a lot of information to go through. The three books that I'm reading are Irresistible APIs, API Design Patterns, and The Design of Modern Web APIs. And I'll share those with you. Okay, so here is the point of API design, in my opinion here, is I want to make a good internal developer platform. And the only way I'm going to be making a really good internal developer platform is I create an experience that encourages software engineers to make good decisions about their APIs and the systems and applications that they are building. The goals of an API design workflow is it provides a process for the engineers to work with each other. It provides a process for engineers to work with each other. There are reproducible API specification artifacts, and there's a general process for eliciting wide API design feedback. The goals of an API design workflow are these three ones so far. The developers are able to work with each other along with the business person to define how the API should work with an outside-in approach. Over time, we are generating reproducible API specification artifacts using the Open API standard. And then finally, we have a process in our organization for eliciting wide API design feedback as much as possible via the computers through linting and other processes. However, also getting feedback from others because they can often see a problem that we do not. And the goal of this optimization is to minimize the time between the creation and realizing that there's a problem with what we've designed. Because APIs are forever, our mistakes are lasting once others build on top of it. So let's go into Irresistible APIs. This is a book that has a lot of really great quotes. I really enjoyed reading it. Irresistible APIs is focused on examples in industry of companies that have created public APIs. In addition, it focuses on the process of designing and the creation of the APIs. It doesn't go a whole lot into how to design an API well, and that's okay. So one of the big points of Irresistible APIs is that the API is part of a developer experience. This is how people work with your business in some fashion. And the point of working with your business is that you want it to be enjoyable and you want people to come back and have a good experience. In the case of Flickr, they didn't build a really great RESTful API, one designed around resources. It was more like the remote procedure call style API, which is simply these actions that you're calling to achieve a goal. Other APIs like Twitter or Netflix are much better designed. However, the reasons why they created those and how they were offered changed. For Netflix, they created this big open ecosystem, but then they made it really hard to use. Ultimately, it led to becoming a very powerful tool for integrating their app across many different devices. For Twitter, they eventually sunset the API because people were using it in a way that started to compete with Twitter as a business. It's something to be mindful of. Some people perceive it as a black eye, but ultimately, most people don't remember it that much anyways. So Twitter is not in a bad position at this point due to the event, though it was jarring for sure. So be aware that as you're offering your API, you want to have nouns. You don't want to have verbs. Verbs limit what you can do. The whole point of an API is to open up the possibilities of what can be done with it. So the API creation process is focused around these ideas of determining what the business value is, what are the metrics that you can measure the API is being used and it's being created. It's creating wonderful things. Use cases are something that is not used enough. The more use cases you can describe for what your API will be doing, the much more likely you're going to be designing a clear and useful API. It really helps facilitate the outside-in API design process. Finally, the API design and the schema model. This comes later. How it all maps to the RESTful descriptions and resources. It's hard work. It's a lot of effort to create an API. The metrics allow you to monitor that it's being used successfully. You can augment things, but be aware that once you release your API, there's some things that are going to be easy to change and other things will be remaining difficult. Some really good quotes in the book. For example, how an API can be like a potato you left in the garage for a couple months if you don't have a clear goal or consistency. I thought that was a pretty good quote. But it is a form of a user interface. And I think the challenge with designing a good API, especially is you can't visually see it. You don't see the obvious deficiencies as you would a physical product. As much as possible, you want to defer filling in the API with actual logic and committing to its design, because you want to find out whether it's going to be successful at all as you've designed it, as the interface is described. The benefit of doing upfront design with your API is that you reduce the amount of frustration and friction when ultimately you need to change something because you've made a mistake or you can't support a certain use case. It seems really abstract. The examples you can think of might be a API that is only gets. The reason that's difficult in the Flickr API in particular is designed around these actions. When a developer that is simply trying to integrate with your software sees it, they're confused. They have to think about it a lot more than they would other APIs. It creates a bad experience. They prefer not to work with your API. If they really have to, they will. Unfortunately, you're not encouraging people to build products on your API if you don't do the work. There's a lot of mistakes you can make with an API. You can think of it very concretely as this pass through to the database. You really don't want to do that. You don't want to put the work on other people to think about your terms and why they're termed that way when you can hide it. The point of the API is to abstract the challenges and the problems with the lower level technologies. You don't want to be telling your consumers that you took the data from multiple systems. It's not really their job to care about it. The point of a design first methodology is that it brings much of the contention to the front of the process and allows for much more streamlined development. It's not easy to see this. You and your developers might be in a rush to get something out the door and delivered, and you don't realize the pain that's happening later on that you're incurring for other people, especially once you do change something, that you can really benefit others by doing the work, putting extra thought into your API's design. So the example I give in this is if you have a factory that makes goods, you wouldn't want to change something about the goods once it's been shipped across the country. That becomes incredibly expensive to change if you needed to slip in some extra paperwork inside that box. So as much as possible, we want to find the problems earlier in the process before shipping the value to our customer and finding a defect. So there's lots of benefits to API first. The challenge that I've seen with talking to engineers, talking to architects and product people with API first, it sounds so good, it sounds so wonderful. There isn't a single way to do API first in a straightforward way. There's a lot of ways that teams work together to design and create their products. Once we get into the code, it's not always so simple, especially the Open API specification. That's not something people are used to working with, especially if they program all day. It's another thing to learn. It's a little bit challenging. It's not how people are used to communicating. So what we're expecting is that it's going to be a little challenging for people to get used to this new paradigm and thinking this way, but it's really important. So as much as possible, even for your internal APIs, think of them like if you were designing them to be a publicly offered API. Copy from other great APIs. If you know an API that does the job it does well, definitely steal from it. There is no shame in doing that. It's not a problem. It's probably going to be much better that you copy others that have great error handling, that have standards that are understandable. They don't surprise us. Usability of an API is paramount. The goal of the API could be varied. It could be around usage. It could be around keeping partners locked into using your ecosystem. There's a lot of reasons why we make APIs. We might think that the product manager or the senior leaders are the ones that need to get clear on the purpose of providing the API. Maybe the product manager and an architect go off, or the senior lead, dev, whoever, go off and they study the business problem and they come down with an initial draft of what the API could look like. There's probably many ways to do it. I don't think that there's one clear way of designing the API, but in this YouTube video, you will see that there are some different ideas about how to achieve it. So some questions you need to answer as you're designing your API. What is the business problem that the API is solving? That's pretty key. What business value is generated by the API? What are the metrics and the use cases that we will define to measure success? And what resources will be needed or available to be successful? And this is an example that the author provides on what a successful API looks like, what it entails. You would think, where's the one box of building it, right? But there's more to software development than just simply doing the code, writing the code. There is the communication, the documentation, the building blocks, the support. Depending on how big your software system is, how many customers you have, some of these might be more or less important. For internal services, maybe support isn't as important. Someone can just email you, that's fine. But as much as possible, we want to deliver value asynchronously and not require our coordination and time to explain how do you use my API. You may need to put in effort into tutorials, reference documentation, defining the workflows, the use cases, maybe giving sample code, tools and techniques. This can be more important for the typically public APIs that companies offer to each other or to consumers. So Irresistible APIs was a great book to read, very informative, a lot of great stories. Kirsten Hunter wrote the book, very helpful, very interesting. Now we're going to go to another book I'm working through. I finished this one, but the other two have not. And this is The Design of Web APIs by Arnaud Lauret. This one is very good because it focuses on how important it is to design your API from the outside in. And it gives a perfect example of the Kitchen Radar 3000. Now you're probably wondering, what is the Kitchen Radar 3000? It doesn't make a lot of sense. Well, it's a microwave. And the challenge that we see in software development is often we're thinking this is the Kitchen Radar 3000. We haven't stepped forward and tried to make it easier for our end users to realize that we're trying to offer them a microwave. What is it that the API is meant to do? We can convey how it works very easily, very simply, yet that misses the point. The point of building software and APIs and abstractions is to make people's lives easier. The reason we like a car like a Tesla is it simplifies the driving experience, uses cleaner technology. You don't need to get under the hood as much as you did older vehicles. That is a much better experience than asking people to drive a manual stick shift car. Some really great quotes at the beginning of this book. The purpose of an API is to let people achieve their goal as simply as possible. Whatever its quality, once people get used to an object and its interface, changes must be made with extreme caution because people are expecting things. It's been defined. They don't want you to change it. An API contract is a promise to fulfill the goals of the API. Once you start changing things, there's communication and coordination that needs to happen. We have to participate in the whole API lifecycle from early discussions to development, documentation, evolution, or retirement, and everything in between. API design is an entire spectrum very similar to the software development lifecycle through the creation, the maintenance, the retirement, the sunsetting. If we focus on what our users are attempting to do, it's going to lead to simpler interfaces. Focus on the use cases. And an API is a software's control panel. The more that we can make it visual, the more likely we'll understand where the deficiencies are. One of the things that Arnaud really recommends is identifying the API's goals. So he starts with these questions, which are really great, and then he's going to go into what the canvas is, and you saw a little bit of that a moment ago. So who can use the API? What can users do with it? How can users do it? What do users need to do with it? What do users get in return for using the API? Where do the inputs come from? How are the inputs used? So the API goals canvas, I really like this a lot. The idea behind this, and I haven't had a lot of success giving people canvases and asking them, hey, fill this out. The benefit of the API goals canvas is that it frames the conversation for our team so that we can understand where the gaps are visually as we collect the information. And what we can learn is when there's missing information or, well, of course they'll need to access this other resource. Well, do we provide it? No? Oh, we better go figure out how to do that. So I like this idea. I think it's valuable. It's definitely one way of many that we could start the design process around an API. So another version of this, and the point of this version of the goals canvas is to focus on, is there some way that we're misdesigning the API because we're focused on how the data is accessed, Because of your organizational hierarchy, you only expose the things that are under your direct control via your organization, when you really should not be limited by those factors. While it seems silly, Conway's Law is a real thing that people do get tripped up on, and the reason is that you can tend to design your systems based on how your organization communicates. Just a high-level definition of Conway's Law. In addition, there's this great REST API HTTP cheat sheet, and here you get really quick information about how you might design one of these HTTP RESTful endpoints, a quick view of when to use post, get, patch, put, and delete for different things, some additional information about query strings, and some more information about inputs, outputs, what do they map to in this realm. The goals are the most important thing. What are you attempting to accomplish when you design an API? And an interesting quote is that an API description format is made to describe a programming interface. Therefore, it must not be used while identifying the API's goals. And this is my emphasis added. Designing the programming interface first without having a clear view of what the API is supposed to do is a terrible idea, Arnaud says, and an API description format must not be used while identifying the concept behind the goals. Now, I think that is definitely his opinion. It doesn't mean that you couldn't be successful doing this. It's just one particular way that you can think through designing an API. In one fashion, it might be that the Open API schema is only a representation of how things should work, and you should spend the time to write up a narrative or create diagrams that illustrate how you should interact with your API. And the API being designed using nouns of resources, not of actions. The purpose of the schema is to flesh out the programmable representation and the data models. One thing that he goes deep into is consistency. You really want people to understand very quickly. If you think of the book, Don't Make Me Think, it is a perfect example of what you want out of an API. You don't want people to overthink how to use your product. It's not good to have to think hard about why you're trying to use a thing. So the 4 levels of consistency Arnaud recommends. There is the internal API consistency, that it's consistent within itself, meaning the different names match that refer to the same concepts, that it's not doing anything too surprising or strange within itself. Then there's consistency across an organization, a company, the team's APIs, consistency with the domain of an API. You can think of a domain like a business problem that your business is solving in one particular area. Typically, you can organize systems, not all systems, but many of them. And finally, level 4, consistency with the rest of the world. You do want to keep your API consistent so that when people review it, they're not surprised or shocked by an interesting new interpretation of how you decided to work with APIs. It's not what people are looking for. They just want to get in, get out, achieve the value they're looking to do. One thing he recommends is creating a design style guide for your organization's APIs, even if it is only for yourself. I can't imagine that's going to be easy or fun, but that's not the point of designing APIs or working in a business anyways, so there shouldn't be a big deal for you to create your own style guide. The point of adaptable APIs are simply to give extra affordances to consumers that would appreciate working with your API. That can be things like internationalization, localization, if you're offering an API in different countries and territories. That could be additional metadata, paging, filtering, sorting, and even hypermedia. The books that I'm reviewing are not going deep into what hypermedia is and how to be a hypermedia REST API. This approach is much more pragmatic. Organized APIs, you really want to be grouping and organizing the information in a way that makes sense, that you're not focusing on hierarchy. The data structures are at a good amount of depth, but not too nested. It only causes more problems. The more that you nest things, the more that there's hierarchy. You don't want an API endpoint to do lots of work and things. You want it to be split out as much as it requires. And then finally, contextual API design. These are the non-functional requirements. They're the concerns as you're developing the API that are not going to be distinct or clear. Asking yourself, is this going to be secure? Can people manipulate or do something with this API they shouldn't have access to? Will mobile applications access this? Because if they can't make lots of calls, then they're going to be in a limited situation. Is this design going to be best for our intended consumers? Can we implement this design with existing systems? There's no point in designing a system you can't actually use or create. Could the documentation be skipped because the design is so clear and succinct that it's not necessary? And will we be able to update our API easily once it is in production? That is a tough question because these changes are hard to undo. So let's go into API design patterns. This is by JJ Giwax. This is also a very good book. It's a lot less focused on the goals and the reasons and the business purposes of creating an API. And that's not bad. It's simply where this book excels is the pragmatic design choices around why or why not you would build an API. One of the main challenges with offering APIs is that because others consume them, one of the challenges with providing an API is that once you do need to make a change to your API, depending on the number of your consumers, it may take an incredible amount of time for them to move to the new version, to learn about the new changes. They may even realize that they don't benefit or do not value new features that are in a new version of the API. This can make it very challenging and difficult to build and improve these APIs if we don't build in good design patterns from the beginning. Like Legos, APIs are building blocks of composition. Some APIs are remote procedure calls, executing logic on another computer. They don't benefit from the RESTful, stateful mechanisms that allow you to conduct a transaction and do additional things. There's use cases for remote procedure calls. There's use cases for resource-oriented APIs. There's no often a good definition of what a good API is for. It's simply, is it achieving the goals that you sought out to achieve with your consumers? If it's being used, wonderful. A good API features 4 things. It is operational, it is expressive, it is simple, and it is predictable. We covered a lot of this in the design of modern web APIs. An operational API means that it's fit for purpose. It achieves a goal. The goals are being achieved. It's clear, it's concise, it does what it needs to do. An expressive API means that you're able to describe simple use cases and complex use cases. The expressiveness gives you the freedom to be able to complete the tasks you need to complete via this API. As much as possible, you want it to be simple, and you want your API to be predictable, meaning it's consistent. There isn't big surprises. One point JJ makes is that Agile is not a good fit for APIs. I know that sounds shocking. The reason is because APIs are forever, it's much harder to use the iterative approach advocated in particular by the Agile development process is difficult to apply when designing APIs. As JJ Giwax says, the iterative approach advocated in particular by the Agile development process is difficult to apply when designing APIs. And the reason it is so difficult is because once you offer the API and it's in use, the contract is solidified. You really can't make many changes without disrupting your consumers. If you have a small audience and you're willing to take on that brunt of frustration from people once you've changed it, that's fine. However, if you have hundreds, thousands of consumers, it's much harder to get them to change. In contrast, a website's very flexible because the entire graphical user interface is not being depended on, and people are able to adapt very quickly to visual changes and still complete their tasks. APIs are designed for computers, which makes them brittle and rigid to change. Computers are not good at adapting. We have to tell them expressly what they need to do when they experience a new issue. Naming APIs is incredibly important. This is part of consistency. You want it to be simple, expressive, predictable, accurate. Prepositions usually mean that there's a bigger problem. Sometimes the context of the API can lead to some misunderstanding around the naming. You can imagine if you have different types of insurance, car and house, they're completely different things. If you're using similar semantics, then there can be instances where you might be confused because the term is being used in a different instance than you're expecting. It's a little vague, but the idea being that naming and dealing with concepts can be difficult. Units and data types are going to convey more information than just a name. So especially if you're doing anything with math type of units or clear data types, will help your consumers know how or what they're going to be using the information for. The challenges can be, and the mistakes you can make when you get your units wrong, similar to the issue NASA had was when one team used the imperial system, another team used metrics, they combined and then a big problem happened because the units were not the same. So just the same idea there. Consistency, we talked about this in the previous book. It's going to only help people think less. The less they need to be aware of some nuance that you're sharing is usually going to be better for them, and it's going to be better for you because you're not creating this new friction for them. Some anti-patterns you can get into with a RESTful API that JJ shares. You make resources for everything. Those are the top level ideas as part of your HTTP API. You don't want to go so extreme that everything is distinct. And you also don't want to create deep hierarchies of data. The more deep hierarchies there are of different data concepts, the more complicated it is to hold it in your head. And then you also don't want to inline everything either. The example he gives in the book is about NoSQL databases where it's very easy to have a collection of books and every collection has a record of an author. However, that becomes very cumbersome over time if you need to update every single book for every single possible author. There's a lot of great information about using data types properly, and the risk you run into with HTTP APIs is that this HTTP RESTful API typically uses either JSON or uses XML text to send data to different systems. The designers of APIs are typically designing their API with their own language in mind, and different languages interpret and understand different types of language properties, either in better ways or typically worse ways. And you'll need to be aware when and how that can cause problems for yourself. The main thing you're wanting to do is obtain consistency with how your API is acting. The first example is dealing with null and missing values. Sometimes in the payload of your JSON, you might have it say null, or you simply do not mention it. You only really want to pick one of these things and stick with it for the entire API. So at least when people do experience it, they know how to act. If you're doing both, it's going to be really frustrating. For Boolean flag, you want it to be defaulting to the true value for the positive aspect of the flag. For example, enabled. That is understandable, and you know that true means enabled. You don't want to choose disabled and then true, and then if you turn it to false, is false disabled meaning it is disabled or not? It gets a little confusing, so try to avoid that. When you are choosing to send over numeric data, unless you're planning to do math with it, you probably want to stick with strings in most cases. Even if the unit is a database ID, unless it has a real meaning around the math or numeric meaning like currency, you're probably better off sticking to strings. You also likely will want to stick with large numbers as strings because different languages will support them differently. It really depends on who are going to be your consumers for your API. If you are pretty sure that your API will only ever be internal, then maybe you don't need to worry. If you are going to serve a wide public audience, then this is something to be careful of. UTF-8 strings, that's pretty standard. Enumerations typically are a bad idea, and the reason they're a bad idea is because different languages may not have support for enumerations. In addition, this causes some additional coupling, because if the server adds another enumeration to the list, the clients will not know that it is available, and they will not be able to call it without getting an update. So that can be a risk that you're willing to take, but it's simply better to be aware what is the coupling you're signing yourself up to? Lists should be atomic collections. So when you make a change to a list, you're sending the whole list back and not just individual properties. And then lists and maps should be bounded by the total number in the collection. You really don't want to be sending a lot more than the data that's provided. A big important thing about APIs is that you will need to do some defensive programming for the information people are sending, because it could be easy to introduce security flaws. The challenge is that you could accept everything they send you, even the data they're not meant to change. So be aware of the OWASP top 10 security issues with APIs. It's a really good resource to avoid potential problems. UUIDs and GUIDs, those are really great ways to get unique identifiers. The problem with them is that they tend to be too long. There can be a bevy of other issues. However, some languages make this very easy to call, and it can be tempting to default to it. The author gives some examples related to base 32, which I didn't really go into depth to cover because it was quite complicated. So I'll spare you, but simply be aware that these can cause you some pain in certain situations. All in all, serialization from a language to RESTful HTTP is a lossy process. You'll probably have to give up many of the nice things about your language to communicate via RESTful HTTP. So there are some do's and don'ts. Avoid offering sorting. That's something that he recommends not doing because it's something that can be handled on the client side. Offering sorting in the long term becomes difficult. You can also filter data, and that's a lot easier to deal with. Filtering data allows you to send less over the wire, and it's usually a good thing. The whole point of standards is really to get the API to a 90% state of offerability. You'll need to make your own calls for your API. There's no resource that's going to tell you how to make a really great API no matter what. In some instances, you may even have to go against the rules. The whole point of the standards are to drive consistency and predictable usage. People don't want to be surprised. They don't want to think hard. They want to use your API to build great things, and you can certainly do that. Simply be aware that there might be some coupling you can avoid, or there might be some design decisions in your API that make it difficult and hard to use, and you can avoid that. One website I recommend going to is aip.dev. If you go to this website, the benefit is the API improvement proposal community at Google. While it is focused on Google's own practices, there's a lot of really great information about designing APIs that it basically comes from the author of this book. And I highly recommend using it as a resource to consider and think through the APIs you can make. I hope you found this interesting and valuable. This is only an incomplete summarization and information from these few books. API design is not easy, it is not simple. I don't recommend you do it alone. Get help, get feedback as much as possible. Thanks for listening.